Alright guys, we're back. This is lesson 6.2. We're going to start talking about properties of parallelograms. Just a quick reminder, yesterday we learned 3 ways to prove that a figure was not a parallelogram. The first of those being that it had an open side, second it had a curved side, or third it had 3 collinear points. So what we're going to do today is start figuring out what the properties of the different parallelograms are. So our targets, as you see up here, or if you can see it better on your paper, that's fine too. Okay, we're going to use the properties of parallelograms. Okay, and we're going to prove that quadrilaterals are parallelograms. So for starters here, we have to define what a parallelogram is. A parallelogram is a quadrilateral with both opposite sides parallel. So as we take a look at this, here's our quadrilateral right here. Okay, here's one pair of opposite sides, so I'm going to go ahead and tick mark those with my arrows or my carets. And I have a second set of parallel sides. This is the definition of what a quadrilateral is, or excuse me, a parallelogram is. Now, because something's a parallelogram, there's going to be some other things that we know about it. I'm going to slide these up a little bit as we go. So a quadrilateral is a parallelogram if its opposite sides are congruent. So in this case, we have one set of opposite sides is segment AD is congruent to segment BC, and the other set of opposite sides are also congruent. That gives us segment AB is congruent to segment DC. Okay, we're going to talk about 5 ways to prove that a quadrilateral is a parallelogram is a quadrilateral. Okay, so when we go back to this, we're going to talk about this first. Both sides have to be parallel. Second, opposite sides have to be congruent. Now we're going to get into the third way to prove it. Okay, a quadrilateral is a parallelogram, then its opposite angles are congruent. So in this case, angle A, the opposite angle of that is C, and angle C are congruent. If angle A is congruent to angle C, and angle D, which will give 2 arcs to, is congruent to angle B, which will also give 2 arcs to. If you see either of these, we know that we have a parallelogram. Now, another way to prove that a quadrilateral is a parallelogram. This time we're still going to stick with angles here, but this time we're going to talk about consecutive angles. Okay, and consecutive angles here are going to go ahead and be supplementary. If you remember back from past lessons, supplementary angles equal 180 degrees. So there's some ways we can go ahead and look at this. We already know from the theorem above that angle A is congruent to angle C. Angle B is congruent to angle D. So one way we can show this is saying A equals X degrees, D down here equals 180 80 degrees minus x degrees. Same thing over here. C is x degrees, so B is going to be 180 degrees minus x degrees. Okay, because of this, when we go ahead and plug any number in for x that's under 180 degrees, we're going to find out when we sum these two together that our total is going to be 180 degrees. Next, what we have here, a quadrilateral is a parallelogram, then its diagonals bisect each other. So we have two diagonals here. We have diagonal DB and diagonal AC. So we're going to go ahead and draw those in. Remember, you can go ahead and use your student ID if this helps. So as we look at this now, I'm going to go ahead and name this part where the two diagonals cross as E. This is going to help us just see what's going on. So AE is congruent to CE. Also, the opposite angles bisect each other. So DE is congruent to EB. So just a way to come over here and write that, I have segment AE is congruent to segment EC, and I also have segment DE is congruent to segment EB. So these are our first 5 properties of a parallelogram. Now this next one here is a theorem. This is not a property, but it is also a way to prove a parallelogram. So if you look here and read along, it says one pair of opposite sides of a parallelogram are congruent and parallel. So let's take the top one for example. Let's say AB is parallel to DC. AB is also congruent to DC. If I have opposite sides that are parallel and congruent, I also know that I have a parallelogram there. Note though, make sure this is up there where you can see it. Note though, this is not a property. But a way to prove it is a parallelogram. A lot of times you're going to see me shorthand it. I'll draw the symbol for parallel and I'll just put O-gram next to it. So at any time if you feel you need to, you can go ahead and pause this video to get the notes written down and go ahead and start up. If you're not sure of something, make sure that you're ready to ask questions right away in class. So here we have a parallelogram. Okay, it's STUV. That's given information to us from right here. We have to find the unknown lengths. Well, what do we know right away? Since it's a parallelogram, we can go ahead and mark it as such. This is the point where we always want to make sure we're tick marking whatever we know. So I'm going to give these two sides. SV is parallel to TU. And 2 carets up here, because ST is parallel to VU. Now, if told us that this is a parallelogram, so now we have to solve for some certain things. If you notice here, they're giving us side lengths. So right now we're not worried about angles. I'm going to go ahead and tick mark what I know about the sides. I know opposite sides are congruent. So I'm going to tick mark SV congruent to TU. I'm also going to tick mark ST is congruent to UV. And I notice I have some information here on the diagonal here. So since W is the midpoint there, I know that VW is congruent to WT. So this is going to get three ticks. And I also know that VW is congruent to WT, so that gets 4. Now as I go through this here, I'm recognizing that here's a piece of information I have. I know SV is 12. Well, they're asking me what TU is. Since it's a parallelogram, opposite sides are congruent. That's going to let me know that TU is also 12. The next thing it asks me is WT. If I'm looking for WT here, WT is this portion right here, from the middle to the upper right corner. So for me to solve for WT, I need to have information on VW. And if you look at your paper as you do, we find out VW right here is 14. And that's going to be congruent with WT. So up here I can write WT is congruent to VW. And since that's 14, we know that WT is 14. Now the next one, JKLM is a parallelogram. Find the missing angles. So right away I'm going to put in the symbols for a parallelogram. Top and bottom I put 1 caret, left side, right side I put 2 carats. Now I got to find the 3 missing angles. So I'm actually solving here for angle J, angle K, angle L. Now going back to my properties, I know in a parallelogram opposite angles are congruent. So I'm going to go with the easy one first. So if angle M is 135, angle K has to be 135. I didn't even have to do any solving. Now, I know that angle M is 135. Well, angle L, these two are next to each other. Okay, these two angles are going to be supplementary. So to find angle L, I go 180 degrees and I subtract the 135. Whatever's left over in this case is 45 is going to be my angle measure here for angle L. And I'll put 2 arcs on that because I know, once again, opposite angles are congruent. So I know angle L is congruent to angle J, and that's 45 degrees. So now we've solved one with diagonals, opposite sides, and we've dealt with one with angles here. Now we're going to throw a little algebra into the mix here. I'm going to do a quick check to make sure you guys can still see it. All right, looks like we can see it there. Okay, we know it's a parallelogram, and now we got to think, what are they asking us? They're asking us about angles. So we go ahead, we put our 2 carats on, caret on top and a caret on bottom. Those 2 sides are parallel. Caret on the left side, caret on the right side. And what do we know about opposite angles? Opposite angles are congruent. So since these 2 angles are congruent, I'm just going to make a small little arc here. I can set these equal to each other and solve for x. So 12x minus 6 is going to be equal to 4x plus 2. Get rid of the smaller variable. And we come up here with 8x minus 6 equals 2. Well, I got to be able to do something with this, so let's go ahead and move the number to the other side. So I have to add 6 to both sides. 8x equals 8. Divide that by 8, and x equals 1. Now let's go back and double check that just to make sure. Okay, so if I plug in 1 here, 4 times 1 is 4, plus 2 equals 6. On this one we have 12 times 1, which is 12, minus 6 equals 6. So both angle 1 and angle A and angle C equals 6 degrees. So we know we've worked it out the right way. And finally, okay, we know that this is a parallelogram because it tells us we have to find the value of x and y. We're looking right away, we're only dealing with diagonals here. And since we've already learned that diagonals bisect each other, these two diagonals are going to be congruent because they're bisected, and these two diagonals are also going to be congruent. So now we got a two-step problem here. I'm going to solve for x first, then I'm going to go ahead and solve for y. So here I have x minus 2 equals 23. Go ahead and add 2 to both sides. X equals 25. The second one I need to solve for is the y. So as I'm going to go ahead and do this, I'm going to pick the one with the variable in it. 2y minus 2 equals 30, plus 2, plus 2. We have 2y equals 32, divided by 2, and y equals 16. All right, I know this part of the notes so far was short. We only got a couple more questions here. I'm just going to check my time real quick so we don't run over. And we're going to go ahead and stop there. We'll do the rest of the problems in class.